Hello scholars, welcome. Mr. Hinkle here. Today we are going to talk about non-renewable energy resources in contrast to renewable energy resources. They are all natural resources, but if we remember, there are two types. Non-renewable are resources that cannot replenish. They are finite in supply on human timescales. So we will add this in, non-renewable equals finite. Energy is the source of power that fuels our society. So today's lecture we will discuss the various types of non-renewable resources, including fossil fuel energy and nuclear energy. We will identify the advantages and the challenges for non-renewable energy sources. So let's talk about fossil fuels. Fossil fuels are just that. So what is a fossil? A fossil is the remains of a once living organism. So fossil fuels are energy that derives from the remains of once living organisms. And through geologic processes over millions of years, these organic material transform into energy-rich substances, and we have three main types: coal, oil, and natural gas. Let's talk about them. Coal. Coal is a solid material that developed millions of years in marshy terrestrial, meaning land conditions, where layers of plant material developed and developed and developed. That plant material was buried underneath the weight of itself and formed peat. That peat, underneath the weight of itself, further transformed into coal. Now, all that plant material that turned into peat, that turned into coal, stored the energy of the organic material, and when we burn it, it releases heat, which we can use to produce steam that can spin turbines that will transfer the mechanical energy of a turbine into electrical energy that we use for electricity to power our homes. Now, coal is a significant source of air pollution and greenhouse gases because the carbon in the organic material transformed into hydrocarbons, which is located within the coal, and is burning those hydrocarbons that produces heat. Coal is a natural geologic material created through geologic processes, but we will not see any more coal developed in our human lifetimes because it happens over millions of years. Oil, crude oil, petroleum, these are almost interchangeably, but the process for how they developed is the same. We just refine them and offer them out in different ways. So similar, crude oil is created by the burying of organic material, but in this sense, it is not the plant material on land that forms swamps, but it is going to be microorganisms in the oceans that deposit at the bottom of the ocean. Bacteria and algae that accumulate in such large quantities. And then same thing, they were buried and accumulated and buried such that over millions of years they were buried deeply, and a transformation came in which turned the organic material into hydrocarbons. And this crude oil is a mixture of organic compounds composed of carbon and hydrogen atoms. That there is the hydrocarbons. So again, a great source of energy, widely available, created through geological processes, but finite in its supply. Natural gas. Same material as oil, but through that transformation, through the development of these fossil fuels, we have a liquid component and a gas component. So we're almost looking at fossil fuels as solid, liquid, and gas, 3 phases of matter. The gas component is primarily the compound methane, CH4, and it is the burning of that methane that again can lead to heat. Natural gas heats our homes. When we put a fire to it, it creates heat energy. So coal, oil, natural gas, these are the big 3 fossil fuels. Fossil fuels have a finite supply because they form from geological processes that happened millions of years ago, and now we have discovered them and are able to extract these resources through the process of mining. Unconventional resources include tar sands or oil sands. It's when we have oil that is interbedded within tars in various locations. This is the tar sands of Alberta, Canada. You can see, it's hard to see, but this is a massive, massive bulldozer, but it looks teeny tiny on this landscape. Tar sands we weren't going to go after tar sands because there was so little oil inside the tar sands that it wasn't economically viable, but conditions can change, prices can change, technologies can change, and conditions for the favorability can change. And so now tar sands is a highly controversial method for mining oil from the environment. I mean, mining in general is controversial, but as you may have heard me say in multiple lectures, society depends on resources. Resources come in multiple types: mineral resources, energy resources. There's non-renewable and renewable resources. And it's not about not using or not mining, or because that would mean we're not here anymore. But it's how do we develop the technologies and the practices to lead to a sustainable coexistence with our Earth, utilizing the resources that we need. Oil shale is another marginal, unconventional type of petroleum. You can see wasn't really popular around the 1950s. The technology changed, and then it had a boom around 1990, and then specific regulations made oil shales less favorable, but it's been recently gaining in quantity of extraction. Because with a growing population, this is a little environmental science, with a growing population, we have greater energy and electricity demands. And approaches: harvest and mine more, develop more, robust technologies that can utilize less, right? So we want to reduce our environmental impact by finding more efficient technologies that can create the same amount of output with less input necessary. Okay, how do we get non-renewable fossil fuels? Well, through the process of mining. We mine for coal, both on the surface and underground. Please see my lecture on mining for various techniques. We drill for oil and natural gas. And that is done by taking a big drill down into the earth, finding the location of the energy resource deposit, and then pumping that back up to the surface, where it then can be refined and processed into the various uses: gasoline, diesel, crude, all of our uses that we have for various oil products. Fracking. This involves directional drilling, so it goes down and then sideways, injecting that drill hole full of chemicals and water that forces open cracks in the rocks, and then pumping the natural gas back up. Another unconventional method that is producing large amounts of natural gas, but controversial because of the amount of chemicals and the wastewater and the potential for contaminating local water supplies. Doesn't matter what type of mining we do, there will be impacts. We need to be thoughtful about these impacts, who's being impacted, and how or what best practices we can use in order to harvest these resources. Nuclear generates electricity through nuclear reactions, right? Through the form of nuclear fission. And basically, all of these methods, in order to generate electricity, we generate heat. Heat can power a turbine. The mechanical energy is exchanged into electrical energy. This happens with nuclear energy as well. The cooling towers, what we see when we think of nuclear energy, the steam coming off, these are cooling towers because of the water that is superheated. Now, nuclear has a bad rap because of nuclear meltdowns, understandably. Chernobyl, 3 Mile Island, Fukushima Daiichi, these are big events that caused a lot of harm. But when it comes to emissions, nuclear is very low emission. When it comes to power, it's very efficient power. When it comes to the waste, radioactive waste, it'll be around forever. I mean, not forever, nothing is forever, right? But radioactive waste generated during the nuclear fission process has a very long lifetime. And so what do we do with this waste? Shoot it into outer space? Bury it in the ground? I don't know. Maybe we could find another use for it. Maybe it could generate more power. Perhaps you're the one to solve that question. Advantages of non-renewable energy sources, right? And our non-renewable energy sources really are fossil fuels and nuclear. Advantages: high energy density. These fuels provide a concentrated and efficient energy source. We have proven reserves for these, and it is a reliable baseload of power that gives us a continuous and stable power supply. We have oil and coal and natural gas that we know. We haven't used it all yet. Society is built right now. We are an oil-dependent society. So the infrastructure is already in place for utilizing fossil fuels and also nuclear power. But the challenges with these are the environmental impacts. The big one, climate change. Burning fossil fuels inputs carbon dioxide into the atmosphere, which is a greenhouse gas. More on climate change at another point. Resource depletion. These are non-renewable resources. They're finite. At some point, they are going to run out. What do we do then? Wait till they're all gone and scratch our heads and go, well, I don't know. What should we do now? The planet's a lot hotter, and maybe we should have done something 100 years ago. Hopefully not. In fact, the world now is working to not have that be the case. Geopolicy. Specific regions are fossil fuel dependent, and their entire economies, so if we remove fossil fuels, their economies will collapse. So there are challenges with having a society based on non-renewable resources, but the current situation is such that non-renewable energy, since the dawn of the Industrial Revolution, has been the dominant energy source for the past few centuries. They're going to run out at some point, and they are currently causing major environmental impacts. And solutions include transitioning away from non-renewable to renewable energy resources. We already use renewable. Right now we have a diverse portfolio of renewable and non-renewable with the emphasis on non-renewable. So how can we recognize that fossil fuels and nuclear are in finite supply also because nuclear happens from the splitting of uranium? There's only so much uranium on Earth. When that's gone, it's gone. For non-renewable resources that are finite, they power our world. We rely on them, and they have helped us achieve amazing things. But knowing that they have big environmental impacts and are finite in supply, at some point we will no longer be able to utilize them as our primary energy resource. And with that, thank you so much, and I will see you in the next one.